Thank you for joining us on this support session for Mechanics 1. This question is to do with Pulley System using a force equals MA formula. And there's a few parts to it. One part where the system is together, and the second part is when the system breaks apart. So let's have a look at this question. Two particles, A and B, have mass 0.4 kilograms for A and 0.3 kilograms, so let's just put here 0.4 kilograms, so that's 0.4 G down for A, 0.3 kilograms, so that'll be 0.3 G force down acting on B. They're attached to the ends of the light inextensible string, so the string does not have any mass, or it will not stretch, so the tension is constant. So we'll put here there's a tension up here, there's a tension up here. Those tensions are the same because they're in the string. It's passed over smooth pulley so that there's no resistance force in the smooth pulley, which is fixed above the horizontal floor. Both particles are held with the strings taut at a height of 1 meter above the ground, or above the floor. The particles are released from rest, and in the subsequent motion B does not reach the pulley. So because we've got a stronger force acting down at A than B, we're going to have the direction of the string anti-clockwise. So let us look at finding the tension in the string immediately after the particles are released, part A, and part B, find the acceleration immediately after the particles are released. We can do these pretty much both of these questions together to gain these 8 marks. So we'll look at the system, let's look at the system A. The system A, because we're heading down, 0.4 G is greater than the tension up. That will result in a mass times acceleration of 0.4 times A. System B, we have a stronger force up than down, so the tension up, take away 0.3 G, which is down, that will result in mass times acceleration, 0.3 times acceleration. Now we have two equations. We can add these two equations to calculate A. So negative T, positive T is 0, and 0.4 G, take away 0.3 G is 0.1 G. 0.4 plus 0.3, 0.7 A. Therefore 0.1 G over 0.7 equals A. Therefore A equals G over 7 meters per second squared. So we've got part B, A equals G over 7 meters per second squared. To find the tension in the string, if we substitute G over 7 in any equation, so let's just substitute A equals G over 7 into, say, equation 1. 0.4 G, take away T equals 0.4 times G over 7. 0.4 G, let's take the minus T across to be positive T and bring this over to be minus 0.4 G over 7. So if we put them both over 7, we get 2.8 G, take away 0.48 G over 7 equals our tension, and that is 2.32 G over 7. Let's just calculate that. Zero 0.4 times 7 times 9.8 divided by 7 minus 0.4 2.8 times 9.8 divided by 7 minus 0.4 times 9.8 divided by 7, 3.36. 3.36 newtons. So we got a tension in the string of 3.36 newtons. Now when the particles have been moving for half a second, so we've got a system where it's accelerating at g over 7. It starts out at 0 meters per second. It's been traveling for 0.5 seconds. We want to find out what happens then when the string breaks. So at some point B comes up a certain height after half a second. So from here to here we've got half a second. The string breaks and then B starts going in a projectile motion, and it says find how long it will take before B hits the ground. So we want to find out, let's assume it's a meter to the bottom. What is this height? And when the string breaks, we've got let's look at what values we've got when the string breaks. We've got a certain height which we need to find out. We've got an acceleration due to gravity of 9.8. Because the system is broken, it doesn't continue with the same acceleration or velocity. It has a certain velocity at the start here, so it's reached a certain velocity after half a second. So we want to find what is that velocity after half a second. V equals u plus at, 0 plus g over 7 half a second, so it's a 14th g. Now that is this direction up, so that the initial velocity, if down is positive, it's heading up. So we will make that a negative g over 14 meters per second. And we need to find how far did it travel in half a second. Well, let's work that out. S equals ut plus half at squared. So it starts out at 0. It then travels at half of a g over 7 times half a second, 0.5 squared. All right, let's get our calculator out. 0.5 times 9.8 divided by 7 times 0.5 squared, 0.175 meters. So 0.175 meters. So this is 0.175 meters above the 1 meter mark. So really it's going to take 1.175 meters before it reaches the ground, and we just need our time. So here we have S equals ut plus half a t squared. We have a quadratic, 4.9 t squared minus g over 14t minus 1.175. Okay, let's just write that 5 again. Therefore, T equals, strange, battery's getting low, so I better hurry. It doesn't seem to be charging. Negative B, plus and minus, let's just do the plus because the negative will give us a time. G over 14 B squared minus 4 A C negative 1.175. Alright, calculator. 9.8 divided by 14 equals 9.8 divided by 14 equals 0.7. 9.8 divided by 14, square that, two negatives make a plus, 4 times A times 1.175. For AC is 23.03. All over 2A, which is double 4.9. At 23.03 plus 0.49 is 23.52. Get the square root of that. Add 0.7. Divide by 9.8. So 0.566 seconds. So we've got our time. It will elapse another 0.566 seconds. All right, not straightforward. Let's have a look at the solution. So part A, we've got 3.36 newtons. Part A, 3.36 newtons. I noticed they've got also 12g over 35, so you could have left it as a fraction. Part B, the acceleration of 1.4 or g over 7, and we've answered it as g over 7. Good. Part C, more complicated. They found the velocity, that it was travelling after half a second. They found how far it had travelled, therefore the total distance 1.175. UT, notice you got a negative because it's in the vertical and everything else is down. So 0.566, good. So we are correct on those three solutions. All right, so this is a question on pulley systems. I hope that you can find questions similar to this and practice them in preparation for your test. I hope by the time you get the test you can do these questions without any problems. But until I see you or talk to you next, stay happy.